Hey guys, welcome to this episode on AWS networking. Recently, we have started a new series on AWS certification guide. So, in this series, we are mainly targeting on the content that is required to clear the AWS Certified Solution Architect Associate examination. In the last couple of videos, we talked about what is cloud computing and different cloud computing models. And today, we are going to talk about very important area of cloud computing. That is nothing but networking, or AWS VPC, Virtual Private Cloud. So to explain the concepts, I thought of going through a practical use case where a particular company, let's call it ABC company, is trying to migrate the existing on-premises network onto AWS. So this is the outline. First, let's talk about the on-premises network architecture of that conceptual company, and afterwards, let's try to model that on-premises architecture on AWS cloud using different construct of AWS VPC. And in the next video, we'll talk about how to secure that cloud network architecture using network security control lists and security groups and different other construct that is available to you in AWS cloud. Alright, so let's get started. So this is our company. Let's call it ABC. So in our ABC company, they already have this setup in the network. So they have this particular IP range. So that's a /28 IP range. And if you're not familiar about this CIDR block, we will get to that as well. So for now, let's say they have some address space or IP range, and that range is further divided to two subnetworks. So this is one of the subnetwork, and the other one is this one. So this we call subnets for short. So as you can see, this company has their web servers in one particular subnet, and that is protected by a firewall. So users from internet can directly talk to the web server. Obviously, this is the web server, so they should be able to talk to the web server in order to view website of ABC company. But this particular subnet can only be accessed by the web server, and it does not have a direct connection from the internet, as you can see. So why have they done it like that? Because in that particular subnet they have the application server, database server. So normally we are not allowing direct access to our database from internet. So that's what they have only given access to their web servers via another firewall to access the database and the application server. So this is the setup, and they want to migrate to AWS. So the sysops guys of this particular company has created an AWS account in AWS, and they are thinking of creating two EC2 instances for web server and for application server and database server. So what they have done is they have created these two servers, web server and another backend EC2 server. And by default, when spinning up EC2 instances, AWS uses its default VPC because all the EC2 instances spinning up by AWS must belong into a VPC. So when you spin up EC2 instances, if you do not specify a particular network or a VPC, AWS will put them into a default VPC, and they will create a public subnet in that particular VPC and put these EC2 instances. But we are going to create our own VPC and create our subnets and set up our network and then place our EC2 instances in the network. So in AWS, we have full control over our VPC. So what really is a VPC, guys? We can consider VPC as a virtual data center in AWS cloud. So in VPC, you have the full control over setting up your network, setting up your security, spinning up different resources in the network, and everything is under your control. And also, it is isolated from other AWS customers. So if you set up a VPC, that is your private environment, and no one has access to your VPC unless you provide access explicitly. So let's create the VPC. So when you create a VPC in AWS, it is always associated with only one region in AWS. For example, in this case, this VPC is belonging to Ireland region or EU West 1 region. So you cannot have VPC spanning across different regions. So that is one of the questions that you will be tested in the examination. A VPC is always belonging to a one region. And when you create a VPC, you have to define your IP address range. And if you can remember, our on-premises network had this IP address range. So this IP address range. Similarly, we have to have an IP address range for VPC. So in this case, we have defined this particular IP address range 10.0.0.0/16. Now, this is a private IP address range. Can we use another number like 11.0.0 something? Yeah, of course you can, but there are some standard IP address ranges, and it is always recommended to use these standard IP ranges, and we call them IRC 1918 standard. So in this particular standard, they have several IP address ranges. One is obviously this one, 10.0.0.0/16. And also we have 172.16.0.0/16, and we have 192.168.0.0/16. Now the format that we have used to define our IP address range is called a CIDR block or CIDR block. So let's try to understand this. So this is 10.0.0/16 CIDR. So in this CIDR block, this 16 represents the 16 bits for the network. So as you know, an IP address is consisted of 32 bits, and out of those 32 bits, 16 bits are reserved for the network in this CIDR block. So the standard way of representing 32-bit IP address is using 8-bit blocks. As you can see, this is a one block, another block, third block, and the fourth block. So the first two blocks is comprised of 16 bits, and that is reserved for the network, and the rest of 16 bits is allocated for the resources. So that means the first two blocks cannot be changed. So that means 10.0 will stay for any IP address in our IP address ranges, and the last two bits can be changed. So let's take example. So what is the starting IP address? So the first IP address is 10.0.0. And how do we count the total IP range of this CIDR block? So that's a very easy calculation. So the easiest way of calculating the total IP count is consider this last number, in this case /16, or it could be /24, and then deduct it from 32. Then you will get the bits allocated for your resources or your hosts, and then take the power of it. In this case, 2 to the power 32 minus 16, that is 2 to the power 16, 65,536. So what is the last address? I told you only last two octets can be changed. So one octet is 8 bits, so that means 255, and the other one is also 255. So you can see the first two octets are never changed because those are reserved for the network, and these two will change. So what is the range? So it will start from 10.0.0 and it will go up to 10.0.255.255. So this is your full IP range that is supported by this CIDR block. Well, one other thing you should understand is although you have this full address range, 65,536 IP addresses in this range, you cannot use all those IP addresses for your resources because AWS reserves 5 IP addresses from these. So it will reserve the first 4 IP address, that means 10.0.0.1 and 2, 3 and 4. So those 4 addresses and the last IP addresses, which is this one. So other than those 5 addresses, you can use any of these IP addresses inside your VPC. And another thing you must know is the maximum site that AWS supports is /16 and the minimum is /28. Okay, so in /16 you get 65,536 IP addresses. In /28, which is the minimum value that VPC supports 16 IP addresses. Right, let's get back to our diagram. Now, this is our VPC IP address range as we have seen. Then let's create two subnetworks within this VPC. You can create multiple subnets inside a VPC. And you have to remember, as VPC is always corresponding to a region, a subnetwork is corresponding to a availability zone. So subnet must always be associated with a single AZ or availability zone. So a VPC associated with a region and a subnet is always associated with the availability zone, right? In AC1, availability zone 1 is dedicated to the subnet 1 and availability zone 2, because in a region you have multiple availability zones. So in, let's say, availability zone 2 is associated with this particular subnet 2. So this is our main CIDR block of our VPC 10.0.0/16. This slash 16 can further divide it to smaller fragment of network in these subnets. So in this case, 10.0.0.0/24 is allocated to one particular subnet, and 10.0.1.0/24 is allocated to another subnet. Now you need to remember another important thing is these IP ranges that we have allocated to different subnets cannot overlap. So what do you mean by overlap? That means any IP address within this range cannot be same as another IP address in this range. So let's take a look. So the starting address is 10.0.0.0 and the total IP count, how do you count it? So you can subtract 24 from 32. So that means you have only 8 bits for allocated for the host. So taking 2 to the power 8, so that is 256 IP addresses. And since the IP addresses are starting from 0, so the last IP address that could go up to is 10.0.0.255. So the range is this. And let's consider the other one as well. So the starting address is 10.0.1.0. And again, since it is slash 24, number of IP is 256. So the last or ending IP address is 10.0.1.255. So if you consider these two IP address range, you can see none of these IPs are conflicting, right? Because in this range, only the last bit changes, and in this case, the third octet value is fixed to 1, and the last bit again changes. So this is a perfectly valid CIDR ranges where we can allocate it for our subnets. Good. So now let's divide our VPC into subnetworks. Okay, now take a look at this diagram. So here we have our VPC and we have created two subnetworks /24/24, the one we just saw, and each subnet is associated with the availability zone. So this is the subnet and this is the availability zone, AZ1, and this is the second subnet and this is the second availability zone. So once you create a VPC, there will be a VPC router automatically configured for you. So this VPC router is basically allowing the communication between the subnets of this VPC. It will make sure subnet 1 can always talk to subnet 2. So we'll get into that in a bit. I'm not sure if you have seen it. I have put the web server, this, in the subnet 1 and the backend server in the subnet 2. Well, when you spin up resources like EC2 instances in a subnet, they will be associated with the IP addresses from the subnet's IP range. Take a look at this example. The web server got associated with this IP address 10.0.0.8, which is within this range, and this is not a reserved IP address as well. The backend server also allocated another IP address from the subnet 2 IP address range 10.0.1.15, which is again not a reserved IP addresses, which is not one of the first 4 or last IP address. And I told you this VPC router allows the subnet 1 to talk to subnet 2. So that is made possible by a routing rule in this VPC router. Let me show you that. Take a look at this route table that is associated with this VPC router. So each subnet must be associated with a route table. So that's another thing that you must remember. For example, you can see this subnet 1 is associated with this route table, and this subnet is again associated with another route table. And both of these route tables, you can see there's a rule or a record saying that if a resource in this particular subnet is talking to another resource which has the destination IP address within our VPC's range, that is 10.0.0.0/16, this route within the VPC. So that's what local means. So if this resource, let's say our backend server, 10.0.1.15 is talking to our web server, which is within this range, and it says route it within our VPC. So that makes backend server to talk to web server. And similarly, in the web server also, we have the same rule. If the web server or whatever the resource is talking to another resource where its IP range falls into this IP range, which is our VPC IP range, just route it locally or route it within the VPC. So it can also talk to backend server since backend server's IP address is falling within this IP range. Hence, any resource within a subnet can talk to any other resource within another subnet inside our same VPC. Alright, so let's continue. Now we need to allow users to talk to our web server over the internet. So how can we make this possible? So in this case, we have to set up an internet gateway for this particular subnet 1 because our web server is in the subnet 1. So we have to connect or configure a internet gateway in the subnet 1. So next, let's look at that. Setting up an internet gateway. Here we go. So this is our internet gateway. So that is another appliance or construct in VPC where we can use to allow our resources to communicate to internet and also from internet into our resources inside the VPC or the subnet in particular. So internet gateway is a managed service which is highly scalable. So this is managed by AWS, so you don't find any single point of failures at this point. And you can associate an internet gateway with a subnet. So how do we do that association? Well, if you can see, I have moved the VPC router from here to here, so it will be more clear. So what we will basically do is we will create another route entry in the route table associated for our subnet 1 that points out to internet gateway. So let's have a look at it. So this is our currently associated route table for the subnet 1. We already seen if there's any traffic destined to our VPC, we are routing it locally or within the VPC. And we can set up another rule. If there is any other IP address that our server is talking to, always take that to the internet gateway. So by putting 0.0.0.0/0 indicates any other IP address except an IP address in this range. So if our web server want to talk to the internet, so it will be an appliance or a server or another machine which has a different IP addresses which fall into this rule, and it will be routed to the internet gateway here. Then from the internet gateway that will be routed to that particular appliance or an server. Similarly, the incoming request will also be routed through the internet gateway into our subnet. Now guys, can you see I have named this subnet as public subnet. Why did we call public subnet? We call a subnet as a public subnet if it has an internet gateway attached and the route table has an entry to the internet gateway. We call a subnet a private subnet if it does not have an internet gateway attached or it does not have any routing rule to the internet gateway. So our second subnet is a private subnet because it does not have any association with the internet gateway. Hope it is clear. Now one other thing I want to clarify. You can see we have used this 10.0.0/16 range for our VPC. Can another customer use the same range? Of course he can. But in that case, how do we uniquely identify a resource in our VPC from another user's VPC? Because there could be another EC2 instance with the same IP assigned to that, let's say 10.0.0.8 in his VPC in a subnet. So how does a resource in the internet uniquely identify our web server and the other EC2 instance which has the same IP? So that is again made possible by internet gateway. So internet gateway does something called NAT. or network address translation. Since Internet Gateway is the first point of contact, we have to assign an public IP address at the Internet Gateway level, or we call it an elastic IP. Elastic IP is a public IP that we assign to Internet Gateway. So the outside resource of the Internet will only see the Internet Gateway's IP address, or the EIP. So the Internet Gateway will map that elastic IP to the whatever the private IP address belonging to the server. So the other user's Internet Gateway elastic IP is always different because it's a public IP. So public IPs are unique. And that public IP can also map to his web server's private IP address. So that's how there won't be any clashes when communicating between resources within the same CIDR block. Alright, so let's move on. Next, we are going to set up a NAT gateway. So what is a NAT gateway, guys? So let's take this example. Now, we already mentioned in a private subnet, we do not have an internet gateway attached. So the outside resources cannot directly communicate to the server. But these EC2 instances, so in this case, the backend server will have our application server and the database, right? So those application server and the database has to maybe run some updates. For example, let's say the database version has to be upgraded. So in that case, this EC2 instance has to communicate with the internet and grab that update and update the database. But it does not have any connection to internet. So how can we make this backend server to connect to internet and get the database updates while any of the resources from outside internet cannot directly access the backend server? So that is made possible by a NAT gateway. Now you can see there's this another appliance called NAT gateway. This is another managed service. So AWS has NAT gateways and NAT instances. So NAT instance is another EC2 instance, but it is not as highly scalable as NAT gateway. So NAT gateway is a managed service which does not have any single point of failures. So the NAT gateway is always placed in a public subnet, and we are creating a route to the NAT gateway in the private subnet. For example, earlier it had only this route, and we are assigning another route which says any other IP addresses outside this VPC CIDR point to the NAT gateway. So for example, let's say our database server wants to talk to MySQL site to get the latest MySQL update. So that points to a different IP address, right? Because that MySQL site has a different IP address. So it will take to the NAT gateway here. And from the NAT gateway, it will talk to the internet gateway here. And it will fetch the update and come back and back to the NAT gateway. In NAT gateway, it does another network address translation here and find the private address of the backend server and send back the updates. So that's how we make the servers in a private network to talk to internet. So I hope you understand this. So by now we covered so many things. So we'll take a look at the things that we must remember for our exam. So I prepared a list of points to remember for the exam. So let's go through them. The first one is VPC is a virtual network in AWS Cloud, and it is isolated from the other AWS customers. We already know. And you have the full control over your VPC. As we have seen, we can set up our network, we can choose our IP address range, we can set up the security. The security part we will be covering in the next video. And here's another important thing. One VPC is always belonging to one region. So VPC cannot span across regions. But a VPC can have multiple subnets. And again, a subnet is belonging to a one availability zone. A subnet cannot again span across the availability zones of that region. And also a subnet must be associated with a route table. We have already seen that. A route table can have multiple associated subnets. So we can define our custom route tables and we can associate those custom route tables with multiple subnets if we want. And also routing inside the VPC is always possible with the VPC router. We have seen that. Let's move on. So these are the VPC constructs. So VPC has the IP address range, the CIDR block, VPC router, VPC route table, internet gateway, security group, network access control list, and virtual private gateway. So these three we'll look at it in the next video. And the maximum CIDR range for the VPC is /16 and the minimum CIDR range is /28. So remember these points, guys. And also we talked that a subnets cannot have overlapping IPs, and also AWS reserves 5 IP addresses from your VPC CIDR range, the first 4 IPs and the last IP. And also if you can remember, I said it is recommended to use the private IP ranges from the RFC 1918 range, which is these three ranges. And this I didn't mention, but it's very important. You cannot change or modify the CIDR block of your VPC after you have created it. So when you create your VPC, it's recommended to use a large CIDR block. So in future, you don't have to worry about like modifying your CIDR blocks. But however, recently AWS announced that VPC CIDR blocks can be extended. You can have like up to 5 secondary CIDR blocks associated with your VPC. We talked about Internet Gateway, and it is a fully managed, highly scalable service, and it does network address translations as well. Alright, I think this is it that I want to cover in this video. And in the next video, let's look at how to secure our cloud architecture with security groups and network ACL. I'll see you in that video. Thanks, guys.